Good morning students, welcome to all. For this session, I discuss the topic electronic configuration. This is the basic, so please be concentrate. At the same time, you need more practice. Okay, without practice, you feel as very difficult. You take some more practice for this session, you can understand very clearly. Okay, you have some confidence about the electronic configuration, children. In lower class up to 10th standard, if I say any one element, for example nitrogen, atomic number 7. Okay, if I ask the electronic configuration, immediately you report 2 comma, okay, so 2 comma 5, that's all. So 5 plus 2 is 7. Okay, but in higher studies it is not like that. You must say 1s2, 2s2, 2p3. Okay children, so in the previous session I talk about the basic for the electronic configuration. Basic means alpha principle, Pauli exclusion principle and Hund's rule. So you must keep the 3 rules in your mind and fill the electronic configuration. Okay, it's very simple children. Okay, so first I recall first one, alpha principle. Okay, alpha alpha principle. This alpha principle explain the electrons are arranged, okay, electron to fill in the orbit in the increasing order. That means 1s, 2s, 2p, 3s, 3p, 4s, 3d, like that. That's the increasing order. Okay, and another one, s orbitals, it occupies 2 electrons. P orbital, it occupies 6 electrons. D orbital, it occupies 10 electrons. And F orbital, it occupies 14 electrons. So you keep in your mind and to fill the electronic configuration. Okay, so second rule, Pauli exclusion principle. Okay, no 2 electrons in an atom have same set of 4 quantum numbers. That means, for example, take the 1s electron, 1s2. Here number of electron is 2. So in number of electron 2, the 4 quantum numbers is not equal. Okay, so N, L, M, S, 4 quantum numbers, principal, azimuthal, magnetic and spin. Here 2 electron. Okay, 1 electron like this and second electron like this. This one clockwise direction, anti-clockwise. Okay, so here you say the word spin. Okay, so 1, okay, so N value 0, M value 0, S value plus half. For the next electron, N value 1, L value 0, M value 0, S value minus half. So N, L, M both are same, but spin quantum number is not same. Okay, so this rule is explained as the Pauli exclusion principle. Okay, so next one, Hund's rule. So in Hund's rule, no pairing occurs. Pairing means this one. Okay, until the rule is no pairing occurs until all the orbitals are singly occupied. That means, for example, p orbital 4 electron. Now to fill in the orbital configuration, p orbital 3 orientation. Okay, here 4 electron, according to rule, first to occupy singly occupied. So next to start the 4th electron here, pairing start. Okay children, so this one for Hund's rule. Okay, so you must keep in your mind and to fill the electronic configuration. Okay, so here electronic configuration give the general formula N, L, X. This is the general formula. Okay, so this N denoted as the principal quantum number. Take one example, 1s2. Okay, 1 denoted as the principal quantum number. This L. Okay, if L value 0, it denoted as s orbital. Okay, s orbital. L value 1, it denoted p orbital. L value 2, it denoted d orbital. L value 3, it denoted f orbital. This concept I repeated maximum times. Okay, maximum all the videos I repeated this concept, keep in your mind. Okay, so next one, this x denoted as electron. Here number of electron is 2, so 1s2 n l x is a general formula. Okay, so what is electronic configuration mean? It's very simple. To fill the electron in the orbitals or distribution of electrons in the orbitals. Now here x electron in orbital, s orbital, p orbital, d orbital and f orbital. So what is the definition of electronic configuration? Distribution of electron in an atom is known as electronic configuration. Okay children. Now I give the practice. First 10 elements in the periodic table. How to write the electronic configuration. Children, nearly minimum 2 or 3 times if you practice, you can feel very easy. You can say the word I know very well. In any element, whatever element I give, you can write the electronic configuration. Okay children. So now go see very clearly. Okay. So first element, hydrogen, helium, lithium, beryllium. Okay, first one hydrogen, helium, lithium, beryllium, 4 boron. First 5 elements, write the symbol. Okay, hydrogen H, helium He, lithium Li, beryllium Be, boron B. Write the atomic number. Hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5. Okay children. Now element symbol and next write the atomic number. This atomic number definition you know very well. Atomic number is defined as, or it denoted the number of electron or number of protons. Okay. So now hydrogen number of electron is 1. Helium number of electron is 2. Lithium number of electron is 3. Beryllium number of electron 4. Boron number of electron 5. Now write the electronic configuration. This is the order. First one write 1s, next 2s, 2p, 3s, 3p, 4s, 3d. Okay children. Okay, so now you write 1s. Here number of electron 1. So write here s orbital only 2 electron. Okay, so more than 2 go to the next orbital. Okay children. Okay, now come to the second one, helium 2. So 1s 2. Number of electron 2. Lithium. First write 1s. Here number of electron, it is possible only 2. Remaining here are 1 electron. So it goes to the next orbital 2s. Here how many electron want to write? 1. 2 plus 1, 3. 2 electron, 1 electron, 3 electron. So here also 3 electron. Next one 1s 2. Next 2s 2. Total number of electron 4. Okay, here 1s2, 2s2. Total number of electron 4. But here number of electron is 5. So one more electron we have. So now what is the next one? 2p orbital. Here 1 electron. Okay children. So this is the way to write the electronic configuration. Okay children, next one you are taking the practice in 11th standard only. This one you didn't study it till the 10th standard. Okay children, so understand properly. Now write the orbital configuration. Orbital, s orbital. S orbital, how many orientation? 1 orientation. Only one box. P orbital, how many orientation? 3. Okay, so here 1s, here how many electron? Here write 1s, only one electron. Okay, so here this one denoted as, it look like that 7. Okay, is denoted as electron. Okay, so here say spin. And next one, this one for half spin. According to spin quantum number, value for this electron plus half. Okay, so next one here 1s 2. So write 1s, number of electron 2. So 1 and 2. Are you clear? Next one 1s orbital and 2s orbital. Next s orbital, 1 orientation, so 2s. Here 1s how many electron? 2 electron. 2s how many electron? 1 electron. That's all. So this is the way to fill the orbital configuration. So next one, here 1s, number of electron 2, so 1 2. Next 2s, number of electron 2. Next one 1s, 2s and 2p. 2p how many orientation? 3 orientation. Here 1s how many electron? 2 electron. 2s how many electron? 2 electron. 2p how many electron? 1 electron. 1s, 2s and 2p. Are you clear, children? Okay, so if you write 1s, 2s, 2p means follow the alpha principle and to fill the electron. Now carbon. Symbol C, nitrogen N, oxygen O, fluorine F, neon 10. Okay, children, in your textbook the atomic number is given as the superscript position, children, but the general concept, the atomic number write in the subscript position. In superscript position write the mass number. Okay, no confusion. Atomic number write in the subscript position. Mass number write in the superscript position. Okay, atomic number writing down the element. Mass number writing top of the element. Keep in your mind. Okay, so now write the electronic configuration 1s. Here how many electron is possible? 2 electron is possible. Next 2s. How many electron is possible? 2. Okay, here number of electron 6. So 2 4, remaining 2. So 2p orbital, 2 electron. Now to fill the orbital configuration 1s, 2s. Okay, next 2p. Okay, p orbital how many orientation? 3 orientation. That's all. Okay, 1s how many electron? 2 electron. 2s how many electron? 2 electron. In 2p orbital 2 electron. If you write like this means this one is wrong. Okay, so according to the rule, okay, that is the third rule. What is the third rule? Hund's rule. Okay, no pairing occurs. So until all the orbitals are singly occupied. So first to fill the single electron. After filling the single electron, next to start the pairing. Are you clear, children? Okay, so now come to the nitrogen. Atomic number 7, mass number 14, number of electrons 7, number of protons 7. Okay, so 1s, 2, 2s, 2. Next one 2p. Already 4 electron filled, remaining 3. So 2p, 3. Okay, so now 1s, 2s and 2p. 2p how many orientation? 3 orientation. 1s 2 electron, 2s 2 electron, 2p 3 electron, 1, 2 and 3. Okay, so 2p, 2s and 1s. Here to mention the axis. This one x axis, this one y axis, z axis. So write like this: 2px, 2py, and here 2pz. That's all. Okay, so next oxygen 8, mass number 16. Write the electronic configuration: 1s2, 2s2, 2p 4. 4 plus 2 6, 6 plus 2 8. That's all. Okay, so here 1s, 2s and 2p. Okay, 2p. So according to rule. Okay, so here 2 electron, here 2 electron, here 4 electron. So first singly occupy the electron. So 1, 2, 3, fourth electron to start pairing. Okay, as like that 2px, 2py and 2pz. Okay, so come to the fluorine atomic number 9. Okay, so now write the electronic configuration. 1s2, 2s2, 2p5. Okay, so now 1s orbital, 2 electron, 2s orbital, 2 electron, 2p orbital, 2p 1, 2, 3, 5 electrons. So 1, 2, 3, 4 and 5. Okay, come to the neon atomic number 10. Okay, so write the electronic configuration. 1s2, 2s2, 2p6. 1s, 2 electron, 2s, 2 electron, 2p. Okay, 3 orientation. Here 6 electron. So 1, 2, 3, 4, 5 and 6. Children, I hope you understand this electronic configuration. So not only up to 10, you take some more practice in 11 to 20 also. Okay, first 11 to 13 I give the example, because after the 2p next to go to the 3s. Okay, so you take some more practice for the electronic configuration. Sodium atomic number 11. Okay, so you know the symbol sodium Na. Like the electronic configuration 1s2, 2s2. Here number of electron 11. Okay, 1s2, 2s2. Next 2p 6. So 6 plus 2 8, 8 plus 2 10. Remaining 1. So next orbital is 3s orbital. We need 1 electron. So fill the 1 electron. That's all. So 1s2, 2s2, 2 plus 6, 3s1. Next aluminium. Symbol Al. Atomic number 13. Okay. So 1s2, 2s2, 2p6. Total number of electron 10. But here 3. So next 3s. 3s, how many it is possible? We need 3 electron. We need to fill 3 electron. But 3s occupies only 2 electron. So remaining 1 electrons. So the remaining electron to fill in the 3p orbitals. Okay. So next example, calcium. Ca. Atomic number 20. Write the electronic configuration. 1s2, 2s2, 2p6. Here totally 10. Okay. So after 2p6, next one 3s2. Okay. So 12. Next 3p6, 18. So after 3p, next one 4s. 4s2. Are you clear, children? Okay, so here 6 plus 2 8, 8 plus 2 10. So total number of electron 20. Are you clear, children? Next example, chromium. Okay, so this element, it is present in D block elements. Okay, it is present in D block series or D block elements. Chromium, symbol Cr. This Z denoted as atomic number. Okay, shortcut method, don't write ATOMIC. So write Z. Same for mass number, symbol A. Okay. So now write the electronic configuration. 24 number of electron. Okay. So 1s2, 2s2, 2p6. Totally 10. Okay. So next 3s2, 3p6. Okay. So next here 4s and 3d. So in 3d orbital, children, first write the 3d, next 4s. Okay, why means both also equal energies. Okay, no energy variation. So here in D block we mentioned first write 3D, next write the 4s orbital. Okay, but fill the 4s first, next alone fill the remaining. Okay children. Okay, so now here 10, 16, 18, 20. Remaining 4. So 3D 4, 4s2. Are you clear? I repeat and write down 3D 4, 4s2. Okay. So no confusion children. Both also equal energy. So like this also is correct. Okay. Now this one expected electronic configuration. But here some changes it occurs. What is the changes here mean? If from the 4s orbital, one electron transfer from 3D orbitals. So now write the actual, this one expected electronic configuration. Okay, actual electronic configuration 1s2, 2s2, 2p6, 3s2. Okay, 3p6. Now one electron transfer from 4s to 3d. So 3d 5, 4s1. So now the correct electronic configuration is 3d5, 4s1. Now you have doubt why the electron is transferred from 4s to 3d4. Okay, so why electron is transfer occurs here due to the symmetry. Okay, so now itself you have studied the word as symmetry. Okay, even in maths also have studied the word symmetrical operation, symmetry. Okay, so symmetry means, for example, if you take the letter O. Okay, so now this imaginary line equal halves we can get, but at the same time, for example, G you cannot get the equal halves, unsymmetrical. Okay, so now here due to symmetry. So symmetry means here 3D orbital, the possible electron is 10. Okay, 10 electron, D orbital. If D orbital 5 electron, if it is present, we denoted as symmetry. Okay, so here also symmetrical D orbital 5 orientation. Okay, 5 orientation, 10 electron. So according to the rule, singly occupied 3, 4, 5, 6, 7, 8, 9, 10. In D5, like that. Okay, 1, 2, 3, 4 and 5. Are you clear children? Okay, so now in D10 as well as D5, the atom is more stable. Okay, in the presence of 3D5 4s1 configuration, now the atom is more stable. Okay, so now ask the question, where in 3D4 4s2 whether the atom is stable or unstable. If arises the question, mean now in 3D4 4s2 the atom is unstable. Okay, so here partially filled electrons in 3D orbital. What is meant by partially filled? P-A-R-T-I-A-L-L-Y. Partially means in that is D5 configuration. If you remove any one or two electron or 3 electron, this one we use the word as partially filled electrons. Are you clear? This one for completely filled. Now in D5 configuration is half filled configuration. From the D5, remove any 2 electron or 3 electron or 1 electron. We use the word as partially filled electrons. Okay, so when the atom is stable, whether it is completely filled in the orbitals or half filled in the orbital, the atom is more stable. Okay children, so now talk about the stability concept. Okay, so in the stability word we use in the chemistry 2 places. One is the radioactive part and another one is electronic configuration. Okay, so now talk about the stability of an atom. Okay, atom is stable or unstable, that's all. So this one is decided by two ways. One is based on the radioactive element concept, and another one is electronic configuration. Okay, so in based on radioactive element, see the definition: a stability of an atom that has enough finding energy to hold the nucleus together permanently. That means center of the atom is the nucleus. Okay, so here proton as well as neutron it is present. Electron is revolve around the nucleus. You know very well, children. Okay, so now here holding the nucleus. That means here proton and neutron. Equal number of proton and neutron if it is present in an atom. Now the holding the energy is very strong. Okay, now the atom is stable. Even a simple word say proton as well as neutron is equal, the atom is stable. Okay, so next one, if neutron value is more than proton, atom is not stable. See the second one, an unstable atom does not have enough finding energy to the nucleus together permanently. Are you clear, children? So based on this radioactive element. Okay. So now your proton and neutron is not equal, mean now the atom it behave as the radioactive element. Radioactive element means you know very well, studied in the physics and nuclear chemistry, the atom emit the rays spontaneously. Okay, only the radioactive element, not all the element. Are you clear, children? Okay, so based on this radioactive element, proton as well as neutrons are equal, the atom is more stable. If it is not equal, it behaves as the radioactive element. Okay, so next one, talk about the electronic configuration. Based on the electronic configuration, talk about the atom is stable or unstable. Okay, it's very simple concept. The outer valence electron is half filled or completely filled. The atom is more stable. Okay, if the atom has partially filled electron, it is not stable, it is unstable. Okay, children, I hope you can understand here very clearly. Okay, so the stability of an atom talk about in two ways. One is radioactive and another one is electronic. Radioactive means here proton and neutron, number of proton and neutron is equal, atom is stable. Now it is not equal, it behaves as the radioactive. It is not stable, it is unstable. So it emits the radioactive rays. Okay, so in electronic configuration, the outer valence electron is half filled and completely filled. The atom is more stable. If it is partially filled electron in an atom, it behaves as the unstable atom. Children, now I write the p orbital, d orbital and f orbital. Okay, so in p orbital, total number of electron is 6. Okay, it denoted as it is completely filled. If p orbital equal to 3 electron, it denoted as half filled. It's very simple, children. So now to fill the half filled, okay, half filled, 3 electron, 1, 2, 3. If it is completely filled, 1, 2, 3, 4, 5 and 6. That's all. Okay. In d orbital, it's possible electron d10. Now, if it is half filled, d5 configuration. Now write the half filled. Okay. So 1, 2, 3, 4, 5. Half filled. If it is completely filled, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, f orbital, 14 electron is possible. 14. Okay, so f7, half filled. So 1, 2, 3, 4, 5, 6, 7, half filled. Now if it is completely filled, 1, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. It is completely filled. Okay. If the element has half filled in p orbital, it is more stable. Otherwise, in completely filled also, it is more stable. In D5 configuration, D5 atom is more stable. Okay. In D10 configuration also is more stable. In F orbital, F7 as well as F14, it is more stable. Okay, children. So next one, they are comparing. Okay, half filled it is stable, completely filled it is stable. Okay, it compare with the partially filled. So partially filled mean, for example, here 3 electron, only 2 electron, it is partially. Okay, half filled, completely filled is more stable than the partially filled. That means half filled and completely filled is more stable. Partially filled, it is not stable. Same way for d orbital as well as f orbitals. Okay, so now you can understand very clearly. Okay, so now here p orbital 3 electron. We use another one word, symmetry. Okay, so now p orbital 3 electron it is present, it denoted as symmetry. 6 electron it is present, it also symmetry, symmetrical orientation or symmetrically distribute the electrons. Okay, same way for D5. Okay, it is denoted as symmetrical distribution of electron. D10, this also symmetrical distribution of electron. Here F7, F14, symmetrical distribution of electrons. Okay, so in chromium example, due to the symmetry, electron it is transferred from in chromium 3d4 4s2. Okay, children, 3d, once again I write the example, 3d4 4s2. So now one electron is transferred from 4s orbital to 3d. So now it changes into 3d5. This one partially filled electron, this one for half filled. So 3d5 and 4s1. So half filled, it is more stable. Next example, this is the slightly variation. Okay, so copper, symbol Cu, atomic number 29. Write the electronic configuration. 1s2, 2s2, 2p6, totally 10. Okay, 10 electrons. Next, 3s2, 3p6, 8 electron. Okay, so here 29. So next one, 3d. Okay, 4s. First 4s2. So how many? 10, 8, 2, 20. Remaining 9. So 3d 9, 4s2. Okay, this one expected. But actual configuration, one electron, it is transferred from 4s orbital to 3d 9. Okay, so now write electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. Okay, children. So now in orbital diagrammatic representation, I take only this 3d as well as 4s. Okay, so 3d 5 orientation, 1, 2, 3, 4, 5, 4s orbital. Okay, 3d 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here 2 electron. Now this one 4s. Here 3d. So one electron is transferred to 3d. Okay. Why? Due to symmetry. Are you clear? And another one reason, due to exchange energy. Are you clear, children? Okay. So now see here. Write again the 3d. So 1, 2, 3, 4, 5, 10 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here only 1 electron. In 4s, 1 electron. Here 3d, 10 electron. So now it is completely filled. This one for partially filled. So in partially filled, it is not stable. the atom is not stable. Atom means copper, it is not stable. But at the same time, in 3D1 4s1, the atom is more stable. Okay, so due to stability, now the electron is transferred. So electron transfer now here 3D10. So we use the word as symmetry as well as, and another one new concept, exchange energy. So electron is exchanged from 4s orbital to 3D electrons. Okay, so now the exchange energy is more. Now it is more stable. The atom is more stable. Are you clear, children? Okay, children, now come to the end of the session. Okay, for this session we see the electronic configuration. It's very simple concept. Use the rule of a principle, Pauli exclusion principle, and Hund's rule. Okay, and to fill the electrons. Okay, so here and some exception case also has some elements. One is chromium and copper. I take the example here and I explain this both also. Symmetrical, due to symmetrical, so now the electron transfer from 4s to 3d. Okay, so here the electron transfer, the main reason is one is symmetrical. Okay, and another one is exchange energy. This exchange energy concept I explain the next class. Okay, children, because this very elaborated one, so I explain the next class. I hope you can understand this session. Okay, thank you, children.